Okay, we should be live now. Welcome everyone. I'm Chanan from Warwick Artificial Intelligence. This is our third episode of Designing Intelligence. This series is all about introducing you to current research in artificial intelligence and applications. So do enjoy the talk today, which is from Mohammad, and this is a collaboration with WFS. So over to you, Mehdi.
Yeah, hi everyone, my name is Mehdi. I am the co-head of the Quant finance team within the Warwick Finance Societies, and this is also our third episode of the Quant Insight that we have started this year. So we are really proud and happy to collaborate with Warwick AI and host Mohammad tonight, who is gonna talk about his research in AI and its use in FX. And yeah, without any further delay, I will hand over to Remo, who is going to present our guest tonight.
Hi everyone, I am glad to present Mohammad Noorbakhsh. He graduated computer engineering at Sharif University of Technology, and he has since completed multiple master's degrees ranging from data science to finance. He is currently a PhD candidate in the mathematics of real-world systems here at Warwick. His research delves into how to use data science and machine learning / AI in drought prediction. However, today we are lucky to have him to present a presentation on how machine learning and artificial intelligence is currently can be used as a way to predict the Forex markets. I'll pass it over to you, Mohammad.
Thank you. Thank you very much for your introduction, and thank you for having me this evening. Yes, I'm going to talk about reinforcement learning in FX trading. So let me share my slide and then okay, can you see my slides?
Yeah.
Yes.
Okay. Okay, yeah, as I said, I'm going to talk about reinforcement learning for FX trading. So the outline of my talk is I started a brief introduction to the FX market, its characteristics, its differences from the stock market and the financial assets being traded in this market, which is called currency pair. Then I move on to the reinforcement learning, its components, its differences from other types of machine learning, which are supervised and unsupervised learnings. Then Markov decision process, policies and value functions, Q-learning, and deep Q networks. Then at the final part of my talk, I will talk about how we use reinforcement learning to trade by presenting a paper titled Financial Trading as a Game, in which the authors build a model to trade in the FX market. Also, I will talk about some additional points that might be useful in creating a trading model. So what is FX markets or Forex markets? Forex market is the largest decentralized financial markets where currency trading occurs with a daily volume of about 6.6 trillion in 2019. According to the World Bank, the total value of a stock traded in 2019, the whole year was about $60 trillion. So that's why FX is the largest financial market. Major players are commercial banks, central banks, money managers, and hedge funds. Global corporations use Forex markets to hedge currency risks from foreign transactions. And there are some individuals or retail traders, a very small portion of all Forex volume are, and they mainly use the market to speculate and they trade. So actually the difference between Forex and if you want to compare Forex with stocks, Forex market is a 24-hour market. So unlike the stock market, which it has, the major stock markets have opening and closing times. So FX market opens on Sunday evening based on GMT when it's Monday morning in New Zealand, which is one of the major financial markets. It remains open until Friday evening, GMT time actually, when the major financial institutions close on the US West Coast. Another thing is the transaction cost, which is much lower in FX market comparing to a stock. And also the liquidity is much higher. Market liquidity is a market feature whereby an asset can be quickly purchased or sold without causing a drastic change in its price. Another thing is short selling FX market, which is it's very easy to do short selling because both ends of assets in FX markets, both ends are cash. And I don't know if you know short selling or not, but short selling occurs when a trader forecasts a decrease in the price of an asset, which the trader doesn't have. So the trader borrows that asset and sells it on the open market, planning to purchase it later for less money and make a profit. Actually, short selling is illegal in some stock markets and in some countries, but it's very common in FX markets. So this is a currency pair in FX markets. For example, this is Euro USD. The currency at the left is base currency. The currency at the right is codes. So when we have the number like 1.30642, it means that €1 is equal to $1.1.30642. So we have bid price and ask price. Bid price is when we selling euro and buying US dollar, and ask or buy price is when we buying euro and selling US dollar. So this is assets in FX markets. We have currency pair, and the currency on the left is always one. So the first thing is about reinforcement learning. This environment, act, goal are the main components of reinforcement learning. The learner or the agent interacts within a specific environment. It takes actions sequentially and receives a reward from the environment. And the goal of the agent is to maximize the total rewards. Actually, the agent is not told which actions to take, but instead must discover which actions generate the most reward by trying them. And this is called trial and error search. And actions may affect not only the immediate reward, but also all subsequent rewards. And this is called delayed reward. These two characteristics are the two most important features of reinforcement learning: trial and error search and delayed reward. Actually, reinforcement learning is different from supervised learning, in which the process of learning is from a training set of labeled examples provided by a knowledgeable external supervisor. And it's also different from unsupervised learning, which is typically about finding hidden structure in unlabeled data collection. So Markov decision process is one, I don't know if it's correct to say this is one class of reinforcement learning problems, but again, it has the same components of reinforcement learning, which is agent, environment, and action. But the thing is, the additional thing in the Markov decision process is states. So in the MDP, the agent must be able to sense the state of its environment to some extent and must be able to take actions that affect the states. So the actually agent selecting actions and the environment responding to these actions and presenting new situation to the agents. And also it gives the agent some reward. So we have a trajectory, for example, here. We are in the environment, it's in state 0. Agent decided to take action A0, and then environment gives the agent reward 1, and it transits to a state 1. So we have something called the dynamics of MDP, which is the probability of transition to a state S prime with reward R from a state S and action A. And also we have the goal, the agent's goal, which is to maximize reward, but not just immediate reward, but also cumulative reward in the long run. We have a concept of gamma here, which is the discount factor or discount rate. It determines the present value of the future rewards, or how much they are important. If this gamma equal to 0, it means that the agent concerns only with maximizing immediate rewards, and which is somehow it's a greedy approach. So yeah. So we have policies and value functions. Almost all reinforcement learning algorithms involve finding a policy, which can we can take a policy as an instruction manual for the agent. So it tells the agent for a given situation or for a given state what the best action is. But at the beginning of the learning, this instruction manual is blank. So the responsibility of the agent is to explore the environment and take various actions, and then it receives some rewards and records everything on its policy. So that policy actually is a mapping from states to probabilities of selecting each possible action. In the policy, we have something called value function, which is the expected value of, or maybe we can say the expected reward, discounted reward from state ST. Actually, we can say that it's how good it is to be in a state S, or we have something like action value function under policy pi. So it means that how good it is to perform a given action in a given state. And then the how good here is defined in terms of future rewards or expected return. So if an agent follows policy pi and it keeps average for each state countered, of the actual that have followed that state, then the average converges to the state's value as the number of times that state is encountered approaches infinity. So we have another concept, which is the optimal policy, and the solving a reinforcement learning task means finding an optimal policy, a policy that achieves the maximum reward over the long run. And this is actually the definition of the optimal policy. So the purpose of any reinforcement learning is to find an optimal policy that gives us the maximum reward over the long run. So I move on to the Q learning. Q learning is actually one of the early breakthroughs in reinforcement learning. It directly approximates the optimal action value function by the following equation. So it's model free and it's value based. So it updates the action value function or Q function based on this equation. So we have discount rates, discount factor. We have a learning rate, which is, or step size, which is determines to what extent new information overrides old information. So when agents decided to take action AT in a state ST, the environment transits to another state, which is ST plus 1. And the agent receives a reward. In the Q learning, we have to update the Q ST AT. So the Q value for the previous state and get an action AT. So let me, the Q learning is, so we have something called Q table, which is actions and states and actions table. So agents, so we first the Q table is initialized. The agent take an action, measures the reward, then it updates the Q table, and then take another action. So this is an example. For example, this is a Q table. So we have states here, and actions on the row and the states on the columns. So for example, if the agent is here, the car, which is located here, so it takes the action in this state with the maximum value, which is going to the right, which is 0.04 here. When it goes to the right, it receives a reward. Then, based on the equation that we saw in the previous slides, it has to update the value of the previous state that it was. So if you can see, this 0.04 becomes 0.95 because it went to on the right hand side and it receives the reward is 0, but the maximum Q value, QSA value was 1 on that state. So it updates the value of the previous state with that action. So we have the deep Q network. In reality, the number of states, if you can, from the previous slides, we have, for example, 6 states and they are all known to us. But in the reality, the number of states is huge, or even they are not entirely known to us. So it's not practical to keep every single combination of actions and states in a table. So the agent would have to maintain action value function as a parameterized function. So in the deep Q learning, replace the Q table with a deep learning model that tries to approximate action value functions. So it is usually referred to as the approximator or approximate function. So the input value to the model is a state, and the output is the approximation of Q values for all actions for the given state. So the thing is that we have to represent the states by feature vectors. The target is this formula, which is adopted from the Q learning from this formula. So the target value is this, and the prediction is this one. And this theta is the set of parameters of the network. In the deep learning, we have a concept called cost function. So we want to minimize this. This is the definition. This is the cost function. We want to minimize this cost function. So this is the target and this is the prediction. But the problem with the Q learning is that the target is unstable. So the target values are changing as we know things better. So the target value for Q depends on the Q itself. So we are chasing a non-stationary target. So how we can resolve this problem? This problem is being solved with two solutions. One is experience replay, which is we maintain a buffer of the old experience, as you can see from this picture. So we put the last million transitions into a buffer and sample a mini batch from this buffer to train the deep network. This process forms an input data set which is stable enough for training. As we randomly sample from the replay buffer, the data is more independent of each other and closer to independent IID, which is independent and identically distributed. So the second solution is target network, which we actually have just one network, which is the prediction network. The target network is a copy of the prediction network. But in the prediction network, we train the model constantly, and the parameters are being updated constantly. But for the target network, the parameters are being updated at every, for example, C iterations. Again, this is makes the target values more unstable, and so we can train this network to generate Q value functions for us. So this is the whole algorithm for deep Q network algorithm, which was introduced by DeepMind in 2015. Okay, so I move on to the financial trading as a game. This is a paper that the authors of the paper tried to build a model to predict, not predict, to trade in the FX, a trading model to trade in the FX market. So the data that they use is tick by tick value from January 2012 to December 2015 for 12 currency pairs, you can see. They encountered some challenges like lack of baseline, data quality and availability, partially observability of financial markets, and exploration dilemma, which is the which is a trade-off in the reinforcement learning, because agent at the beginning of the learning, the agent start to explore, but after sometimes when the agent has a policy, it stopped to explore and exploits what the agent it has, but it's also we have to force the agent to explore as well, not just exploit it. So as I said in the previous slides, we have to vectorize the state space, the states. So this is one example. For example, they create a vector of 198 dimensions. So one of the features is time features. For example, they included minute, hour, and day of a week of the correct time stamp, because in the FX markets, the time of the week is one of the important feature, is one of the important information, because FX market behaves differently at different times of the day or different days. For example, when the major stock markets are open, FX market behaves differently because it's affected by the stock market or affected by the news. So that's why they have included these time features for the states. And another is market feature, which is very obvious, because for any forecasting model, we have to include the previous values. So it's use the open, high, low, close, and volume of the data for 8 most recent log returns. And they also included position features, which is the agent's current position, using a one hot vector, 3-dimensional one hot vector. So action space is a simple action set of 3 values: -1, 0, 1. -1 must be sell, 0 must be no action or neutral, and 1 should be buy. And the rewind function is this formula, which is VT is the portfolio value, so it's a return of the portfolio. So for the model, they use this model. The first 2 are linear layers with 256 hidden units. The activation function is ELU. The third layer is an LSTM layer with the same size. And the fourth layer is another linear layer with 3 output units. So the network has approximately 65,000 parameters. This is their results. Actually, they got very good results. For example, this is the annualized simulation results. For example, CHF-JPY, the return for this currency pair is about 60%, or for GBP-JPY, it's about 40%, which is actually a very good return. I think it's annualized return, so it's a good one. And this is just trading statistics, the number of trades, win rate, average profit, average loss, and expected frequency. So I move on actually to this is some additional actually features that can be considered as the features for the estates. One of them is technical indicators, for example, MACD, RSI, or other technical things, which is technical indicators, some indices that derive from the price itself. So it might be useful to include these technical indicators as a feature for the estates. Another potential features for a state is, for example, the political events, because markets are, especially FX markets, are affected by political events. For example, this is what happened to GBP-USD on the Brexit day. It actually went down from 1.5 to 1.33. So maybe we have to include this information as a feature for the states, and maybe the agents learn to avoid trading on these days, or maybe 1 week prior to these events, because it's very risky, and there's a volatility in outcomes. So it could be this could be a feature actually for this thing. Another thing is the economic indices. This is called the economic calendar, because the governments announce economic indices at a very specific time. For example, this is for tomorrow, and some of them are very important, and they have a great impact on FX markets. Maybe we have included these features for the states, that maybe the agents learn to avoid trade. For example, 1 hour or 2 hours, or even the day that these indices are announced. For example, you have something called non-farm payroll, which is announced on the first Friday of each month. And it has great impacts on US dollar and the major currencies. So maybe we have included this information for the States. Also, for addition to States, we have to include some information for the actions to do some kind of risk management, because for FX trading, risk management is very, very important. We have stop loss order or take profit order. Stop loss is an order attached to your, or even we can include it after you open a position in the market to, for example, to buy or sell, to close your position when you're at loss. And so in the FX market, we can specify how much of your money you're willing to lose. So also take profit is on the other direction. That's when the market moves on your favor. To maybe you said that I closed my order at that price, the specific price. So it might be useful to include the amount of these orders to the actions. So we don't have just a buy or sell. We have, for example, buy with this amount of a stop loss and with this amount of take profit. So we have several long position or buy actions because of the risk management, which is very important in the FX market, FX trading. So this is the references. This is the financial trading as a game, and also the reinforcement learning introduction is a book of the Sutton, which is the most famous book in the reinforcement learning, and it's freely available on the internet. So thank you very much for listening.
Let's see, are there any questions?
Yes, there's one question from Joe Hewitt. He says, you mentioned that data quality and availability was a problem. Could you perhaps go into some more detail on that point and what we could do about it?
Because this was the challenge for the authors. I think one of the challenges, not only the FX trading, the quality of the data. For example, the data might have a lot of missing values that maybe they have to do something with that, or even the availability of the data. I think the data is available, FX data is available, but I think the high quality of data, the data without any missing value or unexpected values might be challenging, or because we can find data, FX data free in the internet, but maybe it's not very high. The quality of that data is not very high. Yeah.
Thank you. And
then we also have.
Go ahead.
Yeah, we have a second question, which is, what was the average time frame for the trade? Was it day trading, scalping, or was it more of a long-term trade?
I think it's tick by tick, so it should be day trade.
So it's quite synonymous to the high frequency trading.
Yeah, exactly, because it's tick by tick, I think. Yeah.
Okay.
And yeah, I think it's very high frequency trading.
Yeah.
Do we have more questions from the chat?
Just to remind everyone, if you have a question, please just write on the chat. Don't hesitate. I have a question of my own in the meantime. So you mentioned that there's a sort of trade-off between exploration and exploitation. How does a network like DQN deal with that trade-off?
We have a concept called epsilon greedy. So epsilon greedy, we specify a probability, and because most of the time the agent is trying to exploit, but when we use the epsilon greedy at probability of epsilon, agents take a random action. So it doesn't take the best action, just a random action to see what is the result. So it's somehow exploration to explore new actions. This is epsilon greedy.
Okay. So how does how would you determine this this probability?
They usually, for example, use, for example, 5%. So 95% of the times, agents use the best possible choice, but 5% of the times they choose the action. The agent chooses actions completely randomly. They usually use, for example, 5%.
We have another question from Joe, and he asked, he wanted to ask you any good ways of getting into the same field or any practical advice for students.
You mean that to enter the FX trading?
I'm assuming data science field.
I think the best thing they can learn. There are many materials online they can use. They can learn actually, or also they can participate in competition. For example, Kaggles. They can participate in this competition, and I think there are many materials which is available online that they can learn. But the best thing is they do some something practical, and I think if they can participate in those competitions are very, very useful. Yeah.
There's a question that mimics a bit of question I wanted to ask you. It's the model that you've just shown us. Do you reckon it can be used for other asset classes such as equities or fixed income? That you have to alter the model somehow to take into account that you're working with a completely different asset class?
Yeah. I think the architecture of the model is. I don't think that's so very important. The important part is the states. So, if, for example, if you want to use this model for other asset classes, we have to specify very useful state features for the states, and includes very useful information for the agents to trade
so
this asset classes.
If we were looking at mentioned data that could have an impact on FX. So if we're looking at stocks, do you reckon this would be synonymous to, for example, using fundamental data such as PE ratios, EPS?
Exactly. PE ratios, or even you can use, for example, sentiment analysis.
Okay.
Yeah, for example, sentiment analysis on the Twitter. You can include as many as information in the state, the vectors for a state, and then feed it to the DeepQ network.
Do you think it makes it's just works just as well, let's say, that you feed in a state that's purely mathematical, let's say, such as technical analysis like MACD convergence, RSI, apart from fundamental data where you're starting to look at the actual revenue of a company. Do you reckon both work as well when inputting it as a state, or, for example, the more mathematical component, let's say, is more relevant?
I actually don't know what's. I think if you include as many as information in the states, either mathematical or either non-mathematical things, I think should be useful.
And
that is useful for the agent to learn, actually.
Yeah. And just one last question, at least from my part. It's at the start of the year, we had another speaker, a strategist from BlackRock, who came in, gave a talk about statistical models. It wasn't AI or machine learning based, and he really gave off the idea that you don't want to be using too many variables, or I guess in your model states, you want to sort of limit it to a low enough number that can represent the model. Do you reckon it's the same when you're working with machine learning and AI, that you want to keep the number of states as low as possible, or do you really want to include as many as you can?
You know, if for example, if you use supervised learning for forecasting, yes, if you keep the number of your parameters or number of the variables as low as possible, yeah, for the supervised learning, that's correct. But for the reinforcement learning, I think we cannot say that if we lower the number of the states, that would be helpful for the agents. I think it's very important to include some relevant information for the agent to learn. But for the supervised learning, yeah, it's very important to have some low number of parameters, low number of variables.
Okay.
So as far as I know, DQN was developed first for a game. I believe it was the Atari series of games.
Yeah.
So do you think that we could see a lot of application of similar techniques to finance? Do you think that we can see a sort of link between AI being developed for games and AI being used for finance?
Yes, I think so. Yeah, because I think because finance, or especially the trading, is very, as I said, it's some kind of online trading, and so the reinforcement learning is very useful for this type of problems. But yeah, because maybe there is a similarity between game and the finance. I mean the trading, because the agent is in a online environment. Learn different things and then try to apply what it has learned in the online environment. Yeah, there might be a similarity between them.
Okay, great.
We also have another question from the YouTube Live. What resources would you recommend to inexperienced coders to looking to build / learn machine learning models?
Sorry, can you say it again? Because
what kind of resources would you recommend to inexperienced coders to build and learn more about machine learning models?
For the reinforcement. Sorry, can you say again?
I'm saying, are there any particular sites or books that you would recommend? Sort of?
Yeah, for the reinforcement learning is this the book that I introduced, the Reinforcement Learning and Introduction. The author is Richard Sutton is the best book for the reinforcement learning. For the other types of, for example, machine learning, there is another book. The basic one is an introduction to statistical learning. It's a very good book. Also Twitter, if you follow some researchers in machine learning, it also is very good resources for machine learning. Also, there are many online courses. For example, Andrew Ng is one of the famous researcher in machine learning, and he has a very famous course in machine learning. Books, for example, another book, The Introduction to Statistical Learning is a very good book for supervised and unsupervised learning.
On that topic, actually, I would recommend joining Warwick Artificial Intelligence because we give lessons and we are developing resources and gathering resources online on our website all the time. So do check our website out as well. Another question from me. So you're a PhD candidate, right? At the moment. So would you tell us a little bit about what you're doing on that?
The topic of my PhD, as I said, it's about drought prediction. So I try to use machine learning or forecasting to forecast drought. The data that I'm using currently is the sea surface temperature, which is a special temporal data type. For example, for forecasting, I try to use different methods of time series forecasting, from a very simple, for example, forecasting in the time series, autoregressive moving average, and also I try to use different forecasting models in machine learning. For example, profits is one of the forecasting framework which is developed by Facebook. Other than for
so now I like to ask, you mentioned time series. I was just wondering what kind of models you mentioned. I think Arima. Do you also utilize other time series models that are widely used in finance, such as the Gauch model? It's a volatility-based time series model.
No, not Gauch.
Sorry, what?
No, not Gauch model.
No.
I use Arima, ARMA, and exponential methods. Okay. And also, I'm trying to apply more advanced methods. For example, I set profits in Facebook, and other than time series forecasting, I try to apply causality in forecast, because for prediction, causality is very important, and one of the hot topics actually in the machine learning, because there are some scientists, for example, Judy Oppert, he says that he actually doesn't like traditional machine learning, and he says that machine learning is just curve fitting. So he's saying that we have to apply causality in machine learning. So I try to do that as well, especially causality in time series. And I'm using a framework, an algorithm, which is PCMCI, which is a causality, discovering causality from time series data. This is very introduction to
a quick side note with regards to the presentation that Mohammad just gave. It will be also up online on the WFS portal on the Quant Finance section for you to have a full read through. Then let's see, are there any more questions? No, I mean, that's it from me. Do you have any more questions, Shannon?
No, not from me. So yeah, thanks everyone for watching. Thank you very much, Mohammad, for coming to speak. It was a very interesting presentation. Lovely to have you on.
Thank you very much.
So our next talk at Warwick AI is on the 3rd of December at 6 p.m. It will be on Facebook and our website, and it's from Stuart Armstrong, who will be talking about every problem in AI is out of distribution behavior. So do come along for that.
And from our end of Quant Finance, we have a workshop on Monday. It will be an options trading workshop, and it will act as a primer for a upcoming options trading competition that we will be doing against the Bocconi Options Trading Club. So we're really looking forward to that, and please do come if you'd like to learn more about what options are, how to trade them, and how to price them as well from a quantitative point of view. And this event is also done in conjunction with the markets team at WFS.
Great, thank you. Thanks for coming.